So we're going to look at the complex plane. A lot of this is review of things we did last year. The real number axis, so the horizontal axis, the vertical axis, the imaginary number axis. So if we looked at point A, we have to go right 1, 2, 3, 4. So it's the real number part 4, up 1, so plus I. It's kind of like the coordinates 4, comma 1, except the x number corresponds with the real number, and the y number, the over y coordinate, is the I number. And we could write one I if we wanted to, but most people just put I. With your partner, you should take a moment and write the coordinates for B through E, and then also answer question number 2. Okay, so for B, let's see, Zach, what did you get for B?
3i.
3i. Okay, pick somebody for the next 2. Next one? Here. And the last one?
4 minus I.
Which pair are conjugates of each other? A. Okay. If we look at the graph, what's the connection between A and E? What transformation can we do to A to get E or E to get A?
Reflect over the x-axis.
Okay, right. We can reflect over the x-axis. Conjugates are reflections of each other over the x-axis. The x-axis is the real number axis. When you go through your assignment, you're going to have some computations with these imaginary numbers, and they're going to ask you things like, what kind of transformation do you do to get from one to the next? So if they ask about conjugates, well, they're reflections over the real number axis. Some of the computations might lead to rotations or reflections, those kinds of things. So that makes it go. Magnitude. Magnitude, you've done that before. This symbol here, around the Z, what's that been called before? Absolute value, right? Absolute value measures the distance from 0 on a number line, extend it to the complex plane, distance from 0, 0, or distance from the origin. So if we're asked to find the magnitude of -2 plus 7i, plot a little sketch of it if I want to. -2 plus 7i, so here's -2 plus 7i. I have to go left and out. And then we have, okay, so we want distance. Makes a nice little right triangle up here. Side length is 2, side length 7. So 2 squared plus 7 squared is our distance squared. 53 is our distance squared. So we have positive or negative. Square root of 53 is our distance. We're dealing with a magnitude or a length, so we don't have to worry about the positive square root. And you've done that before. Just find the distance between that point and 0, 0, basically. With the partner, figure out at least 2 examples for number 4. Jackson, what was one that you had?
5 minus 12i.
5 minus 12i. So if you remember the 5, 12, 13 right triangle, you could use 5 and 12. Quadrant 4. So your positive real number, negative imaginary number. Anybody have one that didn't use 5 or 12? let's see, David, did you finish the one you were working on?
I did,
Okay.
the square root of 133, so haven't simplified that yet.
Okay, that's fine. Square root of 133, you said?
Yes.
Okay. And then minus
1/6.
6. Okay, so one way you could do that, I think, which David was look at, you just pick the number 6 squared plus b squared equals 13 squared. You figured out what b was. Then just made sure that one was the real number part, one was the imaginary part. Norm, your book talks about norm a little bit, and it's just saying take the number times its conjugate. It's called the norm. And the reason they talk about the norm is because that's another way you can find the magnitude. So here it says find the norm. So the norm of z was z times its conjugate. So in this case, we have -2 plus 7i. What's the conjugate of -2 plus 7i? Andrea, what's the conjugate of -2 plus 7i? Exactly, -2 minus 7i. Okay, so take a moment, multiply that out. Multiply that out and see, I get 53. Well, we have to do this to get back to the magnitude. So what was your magnitude on the previous problem, previous page? What's that? No, I'm sorry. For -2 plus 7i, because you found the magnitude, before we worked with the 13, we found the magnitude of -2 plus 7i. What do you get for the magnitude of -2 plus 7i? Square root of 53. So that's saying we can either think of plotting it and finding the hypotenuse, the distance between 0, 0 and that point, or you can do the norm and then square root. Personally, I like to plot it in the plane and look at the length. It's easier for me to remember. But this is an alternative. Argument, you want to think angle. How many degrees do you have to turn from the positive x-axis to get to your number? So if we're looking at the argument of -2 plus 7i, first thing I would do is plot -2 plus 7i, so -2, 1, 2, 3, 4, 5, 6. So here's -2 plus 7i. Okay, that's as a point. Your book will tell you sometimes plot the point, plot the number as a vector. Okay, to make it into a vector is pretty easy. Just connect that point back to 0, 0. So now we're starting to look at, we have a length of that red line, and we have an angle to turn, which is the argument. And that's the basis of what we'll look at. It's called polar form, where you tell somebody how many degrees you rotate, and then once you rotate it, how far do you go to get to the spot. So we want to find this angle here. What are your ideas? How can I figure out that angle and mark it red? Work with your partner, figure out that angle. Okay, so I just walking around, mostly have the idea. You can just make a right triangle, then you can use your normal sine, cosine, and tangent things. I like to use what's given, so I'm going to use the 2 and the 7 side. And when I draw the right triangles, I like to draw them always along the x-axis first to mimic what we did last chapter. I saw Garrett and Zach drew the triangle across and then down, so they found this angle, and that's who we added 90 onto it, which is, it's fine, it's equivalent. Like I said, I just got to have it always drawn one side along the x-axis. So we get 74 degrees, and then we're looking at it. Basically, here, basically turning, we're short of going to 180, we're 74 degrees short of going to 180 degrees. So our argument, which we abbreviated as ARG, of negative 2 plus 7i, be 180 degrees minus that angle we found inside the triangle. And that came out to be about what? About almost 106, right? 105.9. Don't forget your degree symbol. If you don't put degrees, radian measures implied. Radians is 105 radians is a lot different than 105 degrees. Let's see, let's look at A together, and then I'll have you work on B through D with your partners. So we're in the plot 4 plus 3i. I like to graph these. 1, 2, 3, 4. So here's 4 plus 3i. And I'm just going to draw it as a vector. And again, that just means connect the origin to the point. Go there. Sides. Now we have a right triangle. The vertical side is 3, horizontal side is 4, and I'm going to call this angle A. So for A, tangent of A is opposite over adjacent. So A would be the tangent inverse of 3/4. And what is that to the nearest hundredth of a degree?
36.87.
Okay, 36.87 degrees. If you didn't get 36.87, check your calculator. You may still be in radians from the things we can do. Do we need to add that onto 180 or subtract it or do anything with it? No, we're in quadrant 1. So our argument of 4 plus 3i is about 36.87 degrees. And then our magnitude of 4 plus 3i, what's our magnitude of 4 plus 3i? Just think a squared plus b squared, square root it. We end up with 5 because we get the square root of 25. That's also a Pythagorean triple. So the nice thing is, if we take this 4 plus 3i and reflect it into other quadrants, we should get the same basic triangle. Just so we have to figure out, do we take the angle we found and subtract it from 180, add it to 180, or so on. So with your partner, figure out the magnitude and argument for B through D. So you can check your work with the answers that are out here. On B is in quadrant 4, so you're just short of doing the complete 360-degree turn, so I subtract. C is in quadrant 2, so go left and up, similar to the example of negative 2 plus 7i. And then D, you're in quadrant 3, so go left and down. So that puts you past 180 degrees. That's why it's 180 plus. Make sure you put the degree symbol on there. If you don't put degrees, remember radians implied, and radians is different